Hello and welcome to Soft Papers channel. My name is Godfrey. I'm an experienced teacher with the Cambridge International Curricula. In this video, I'll be solving physics topical question, work, energy and power of 2019 November. I encourage you when you're preparing for your exams, your coming exams, especially in 2021 exams, purpose to revise using topical questions. Topical questions help you to throw light on areas which the examiners frequently do examine. Here in Soft Papers, we have compiled physics topical questions, which you can find them in my website. I encourage you read a given topic, read your notes, read your textbook, and get the topical questions that will be set in a given year and attempt those. In that way, you'll have a good chance of not be able to forget the key areas of a given topic. And without much ado, I would like us to get started. Question number one. And before we get to this question number one, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will not miss any upload that I do of the coming videos. Question number one. Brakes are used to slow down a moving car. Into which form of energy? Which form of energy is most of the kinetic energy converted as the car slows down? Of course, you know, we have many different forms of energy. We have chemical, we have elastic, we have thermal, we have sound, we have light, many forms of energy. Here is a moving car which has got kinetic energy. Of course, when the brakes are on, the brake pumps will come into contact with the rotating wheel disc, and that will cause friction, and friction will always generate heat energy. So the kinetic energy of the moving car when the brakes are on will be converted to thermal energy. So that is the answer to question number one. Question number two. This question, of course, once you see every question has been indicated which paper it has been set from. This is question number 11 that has been picked from Physics paper 1-2 of October-November 2019. Which source of energy is non-renewable? Of course, you know, we have non-renewables and we have renewable energies. Of course, among all these, oil is the non-renewable form of energy. Oil is non-renewable energy. Solar, tidal, and wind, all these are renewables. All these are renewables. All these are renewables, energies that will not run out with time. Question number 3. This question, of course, was set on this question number 10 on Physics paper 1-1 of October-November 2019, which does not transfer useful energy. Of course, useful energy is that form of energy that does useful work. Of course, emitting of sound waves. Does emitting of sound wave do useful energy, or does it does it transfer to useful energy? Yes, it does. Emitting a sound wave will transfer a form of energy, form of information. Sound wave can transfer information, and that's how we get to here. So this is correct, will transfer useful energy. What about measuring a temperature? Basically, when you measure a temperature using a thermometer, when you use the thermometer absorbs energy into the bulb where there is mercury, and then the mercury expands. Now, the expansion of mercury inside a thermometer does not do any useful work. So the answer to this question is B. Okay. What about passing an electric current? Of course, when you pass electric current, this electric current will only flow when the circuit is complete, and therefore it will light a bulb if there's a bulb in the circuit. So that is a useful energy. Electrical energy transferred to light energy. What about push a box along the floor? How does that do useful work? I mean, useful energy. Of course, when you push a box along the floor, of course, you've moved it from one point to another, so you have done work. So that is a form of useful energy. Very well. So the answer to number 3 is B. Let's go to question number 4. Question number 4 is from paper 1-1, variant 1-1 of October-November 2019. And this is question number 11. You can always confirm these kind of questions from the past papers. So the power output from a solar panel, the power output on a solar panel is recorded every day for a month. The graph shows the output recorded. Of course, this is the power output. This is power out. This is power out. Okay. This is power out. Power out. Then on the x-axis, we have day of the month. So this is be recorded for a whole month, right? We don't know what month this is, but the graph shows the output recorded. Of course, you can see the solar panel receives the energy from the sun, and of course the variation here is indicative of the energy that is coming from the sun, that is output from the solar panel. So what is the question here? The question is which conclusion can be drawn from this graph? Which conclusion can be drawn from this graph? A, the power output from the solar panel changes from day to day. That's obvious. Of course, on day 1, the power output was there. On day 2, it is air. Day 3, the power output increased. Day 4, decreased slightly. Day 5, decreased. And therefore, this is changing. This is changing. So the power output from the solar panel is changing. And therefore, without much ado, the question is A. Of course, you can look at the other choices. B, the power output from the solar panel is cheap to produce. Of course, that is true, but that is not indicated in the graph. The graph does not, there's no way of knowing that from the outputted power from the graph. So B cannot be correct. Solar panels create no pollution. Yes, they don't, but there's no way of telling that from the graph, because we are told which conclusion can be drawn from this graph, So you cannot draw this conclusion from the graph. We know that, but the graph does not, there's no way the graph is telling us that. Then the solar energy is renewable. We also know solar energy is renewable, but from the graph, that we cannot tell. Very well. So the answer to this question is the power output from the solar panel changes from day to day. As you can see, the graph is not a straight line. Question number 5. Question number 5 is from variant 1-2 of physics paper of October-November 2019. This is from question number 10 in that variant. And the question is, what is the unit of thermal energy? What is the unit of energy in short? Of course, we have different forms of energy, as you know. Chemical energy, light energy, sound energy. But what is the unit of energy? Of course, air. This is the unit of temperature. of course, that's not energy. B, this is a unit of force. That is not energy. And C, of course, joules is the unit of energy, and therefore the answer is C. Of course, D, this is the symbol for work. This is the symbol for work. Is not the unit of energy. It's not a unit at all, sorry. So the answer to number 5 is C. Question number 6, of course, which was from variant 1-3 of October-November paper 2019, number 10, right? So 3 situations are listed. 3 situations are listed here, and we are told that someone, situation number 1, someone blowing air into a party balloon. That is one situation. A crane lifting a block of concrete. Number 3 situation, a pile of books at rest on a shelf. In which the situation is work done? Of course, we know that work is equals to force multiplied by distance or displacement moved by the object in the direction of force. Therefore, in these 3 situations, which one is motion indicated? Now, when you blow air into the balloon, you are already the balloon, right? Then this means that although the balloon is bulging, the balloon is not moving. There is no distance, right? You are blowing air. Of course, blowing air is force. You're pushing air forcefully into the balloon, but the balloon is not moving, and therefore there's no work done in blowing air into a balloon. And a pile of books at rest is not moving, right, on a shelf. So the force of gravity is acting on this pile of books on the shelf. Therefore, there is force, but the books are not moving, and therefore no work done. Situation 2, a crane lifting a block of concrete. Lifting. So on top of the force that is exerted to lift this concrete by this crane, the crane is able to move the blocks, and therefore work is done on lifting these books on this concrete, and that is the work done on this question. In which situation is work being done? All right. The work is done on 1 and 2. We had said that work is not done on one because the balloon is not moving. But of course, since the balloon is increasing, it is pushing against the atmospheric air, then work is being done on the balloon. So that is what makes number 1 to be correct. Although the balloon is not moving, from the context of balloon moving, work is not being done. But on the context that the balloon is pushing against the atmospheric pressure, then work is done. Very well. Question number 7. Question number 7 is from Physics paper 1, variant 1-3, October-November 2019, number 11. And what does question 11 say? A boy lifts a brick from the ground and places it at a rest on a higher shelf. He does 30 joules of work against gravity, right? Which law correctly describes the final energies of the brick? All right. Of course, we on column 1, we have gravitational potential energy gained by the brick in joules, kinetic energy gained by the brick in joules. So the question is, which law correctly describes the final, right, energy of the brick? So once the boy is lifting, when the boy is lifting the brick has got kinetic energy. As long as it's moving up, the brick has got kinetic energy, all right, while moving. While moving up, the brick has got kinetic energy when it is moving up, but when it is come to rest, then there's no longer kinetic energy. The brick does no longer have kinetic energy. All what it has is gravitational potential energy. Okay, while at rest, up. Okay, when it is come to rest at higher shelf, then it has gravitational potential energy. And therefore, how much gravitational potential energy does this brick have? We are told that the boy has done work of 30 joules against the gravity. And we know that, of course, work is equals to force times distance. And we know that GPE is equals to mass times G times H. Of course, you can expand this force to mg because it's moving up. So basically that means weight times distance. Distance here could be same as height. And therefore we can equalize to say that work done is equal to the gravitational potential energy gained. And that means that the brick, if the work done was 30 joules, then the gravitational potential energy gained is also 30 joules, right? So that seems to be C. And of course, when the brick comes to rest, kinetic energy is equals to 0 at rest. It's not moving, right? Therefore, that makes the answer to be C. Very well. Question number 8. This is extended. The question is from variant 2-1, October-November 2019, numbers 11. So this is a question for the extended, but it's also good practice even for the core. Those guys who are doing core. Now, a man carries 20 tiles from the ground to the roof of a house. Carries 20 tiles from the ground to the roof of the house. Each tile has a mass of 1.2 kilogram. The roof is 15 meters above the ground. How much work does the man do against gravity on the tiles in carrying them to the roof? Of course, the first thing is to find the weight of these tiles, right? And therefore, to find the weight, you go the direction of mass. Mass is equals to 20 number of tiles. Each tile is 1.2 kg. Each one of these tiles is 1.2 kilogram. And therefore, the total mass of these tiles is 24 kilogram. So what is the weight of these tiles? Weight is equals to mass times gravity. And in this case, of course, mass is 24 kilogram times gravity, which is 10 Newton per kilogram. This gives us 240 newtons. Now, he has carried this weight, which is force of gravity. He has carried this at a distance of 15 meters above the ground. So we know that work done is equals to force times the distance moved. Okay. In this case, he had applied a force of 240 newtons at a distance of 15, moved it at a distance of 15 meters. Therefore, 240 times 15 will give you 3600 Newton meter or 3600 joules. Newton meter and joules are equivalent. Therefore, the answer is D. The answer is D right there. Question number 9. Question number 9. This question appeared in the 3 variants of 2-1, 2-2, and 2-3. And in 2-1 and 2-3, the question was number 12, and in 2.1 and 2.2, the question was in number 12, and then in variant 2.3, the question was question number 13 of October-November 2019. Okay, so a car is moving along a straight horizontal road. The car's kinetic energy of 1.6 megajoules. The car accelerates for 20 seconds until the kinetic energy of the car increases to 2.5 megajoules, right? What is the minimum average power developed? Minimum average power developed by the car engine for this acceleration. Okay, so we can see the kinetic energy has changed from 1.6 to 2.5. So let's find the change in kinetic energy. Okay, change in kinetic energy is equals to 2.5 minus 1.6. This gives us 0.9 megajoules. 0.9 megajoules. Now, we know that power is equals to energy over time, or rate of change of energy. Okay, now the energy that has changed here is 0.9. Mega is 10 raised to power 6, of course, joules, and this has occurred at a time of 20 seconds. 0.9 divided by 20 seconds. Of course, this will give you 45,000 watts. Of course, you can change the 45,000 watts to kilowatts, and therefore this will be 45 kilowatts. 45 kilowatts. Kilo is 1,000. Kilo is 1,000. Mega is 1,000,000. That's why we have used 10 raised to power 6. Of course, 1,000,000 in standard form is 10 raised to power 6. Kilo in standard form is 10 raised to power 3. And therefore, the answer is C. Very good. Okay. Question number 10. Question number 10. Of course, this is from variant 2.2. This is number 12, October-November 2019. All these questions were October-November variant examination series of 2019. So number 10, a box of mass 8.0 kilogram is lifted from the ground and placed on a shelf. Of course, from ground to a shelf, not that. The box gains 100 joules of potential energy, gravitational potential energy, of course. The box falls off the shelf. Air resistance is negligible, so it can be ignored. What speed does the box hit the ground? Of course, when it is falling from the shelf, it has got 100 joules of GPE. Therefore, as it falls down, the GPE is being converted to kinetic energy. Therefore, we want to know what is the speed as it hits the ground. At the ground level, all GPE will be converted to KE, and therefore we can basically say KE is equals to GPE, and therefore that is 100 joules. And we know that GPE is basically the energy that the box is having on the shelf. Therefore, we can say now kinetic energy is equals to 100 joules. And we know that the formula of kinetic energy is 1/2 mv squared is equals to 100 joules. we want mass. We are not given mass of this. We are given the mass. Yeah, we have the mass here. The mass is 8 kilogram. Therefore, we make V subject. V is equals to square root of 2 times 100 divided by mass, which in this case is 8. Therefore, when you find the square root of that, of course, you'll get 200. When you multiply 2 times 100 and divide by 8, then you find the square root. Find the square root of that. 200 divided by 8. This is when you divide by 8, this is 1. This is 2 for 16, then 5. So then you get the square root of 25, which is supposed to be 5 meters per second. So the answer is B. Number 11. Lastly, number 11 is from variant 2-3 of October-November 2019, and this was question number 12 in that paper. A force of 25 newtons acts on an object. The work done by the force is 400 joules. How far does the object move in the direction of force? Of course, this is quite straightforward. Work is equals to distance times force. We desire to calculate distance. Therefore, distance is equals to work over force. Work here is 400 joules, we are told, right here. And then the force is 25 newtons. When you divide 400 divided by 25, you get 16, and this is going to be meters. So the answer there is C. Those are the questions that were set on October-November exam series in Physics IGCSE, both core and extended. And I will encourage you to look for other questions in other work, energy, and power questions in the May exam series, and you'll be set for the forthcoming exam on this topic of work, energy, and power. Hope to see you in my next video. Bye.